Hi, if this is working. I'm sorry if we sound a little out of it today. We played too many Leagues of Legends. It was awful. I do poorly. I do okay. But okay's not good enough, you know. You gotta be the hero. So we're going to plug in and continue programming our auto water. We have stuff outside we want to water, and we have the technology to do so. So let's get these. Let us get this arranged in a more sensible fashion. How about it? Alright, that looks better. We need to open up a serial port to COM13, I think. Let's have a look-see. How about automatic scene switcher turns off for now? Cool. Do that. Back to little monitor. What's this overlay for? Oh, we don't even have the right chat set up. Oopsie daisy. Yeah, COM13. Go back to Putty. We're gonna open a serial port. Shillelagh. Now I got some working on this that I need to do before we actually get to doing. One moment. Oh, sorry about that. We'll get some kind of a chat bot open so I can see what you're saying. If you're saying anything. You might just be staring creepily. Anyways, let's while I think about what I need to do here, I need to do Putty so that we can see the serial monitor. While I think of that, let me show you what I got going on circuit-wise. Okay, so... Oh! Update? Sure, yeah, why not? Get out of my way, though. Thank you! Alright. So... I may just unplug the serial monitor. And, oh, there it goes, goodbye. And one of the peripherals. Okay. No, let's just do it all the way down. I'd like you guys to see this thing in all its majesty. Anyways, what we got going on up here, I'll explain the peripheral first. We've got a soil moisture sensor. Let me grab a fresh one. Here's one that has a component missing off of it. So, nifty little thing. I think it's based off of 555 or similar. I don't know. I haven't really done the ripping it open to find out, but if you have a peek up here, let's alter our camera so you can see this. I should have just left that open. Hindsight is perfect 2020, isn't it? Anyways, you can see that when this thing shipped to me, U2, which was a voltage regulator, was mysteriously missing on the board. Oh boy. So, the company I ordered them through was kind enough to send me 2 more for free. Always love when that happens. So, let's get this linked. Here we go. Alright. We do have chat. So if anybody's around to say hey now, I can see it. We'll put on a restream link to display your guys' chat soon. No guarantees. Anyways, yeah. So you may notice a little fliggity flick switch here. I've got that installed because when I'm programming this is pulling something high and the chip doesn't like it, so I just disconnected it. Probably would have made more sense to disconnect the power to it, but you know, me and my big ol' brain, we like to act before we think, so hindsight's perfect. I'm sitting here thinking, why didn't you just disconnect one of the powers and then the chip won't output anything? Gosh golly. I do wish I had done that. This is giving us some trouble. This is not an ideal method to join 2 boards together, but there we go. Just gotta work at it, you know? Oh, it is not happy. There we go. Now it's happy. Gotta work all them. So the chip itself is on proto board. It's really basic. We just have more light. How about that? We just have a dip 8 socket here. I need an instrument of which to point. Do I have a pointing instrument? Mouse? Mouse? I'll use this! Okay. Alright. So it's primarily just a dip socket and a bunch of things to break it out. This guy. We got our serial outputs here. We've got an analog output here. We've got an analog output here. It goes from left to right. Analog output, power, ground, 5 volts of course, because we're dealing with 5 volts. 2 capacitors, just to decouple some things, you know, yummy, and then a power breakout. This was actually a mistake. This was originally going to be my serial line, but I forgot that serial needs to tie the two chips grounds together. So I was like, well, I'm not desoldering it. Screw that noise. And then up at the forefront here, we just got a micro USB socket, power only. The data lines are not hooked up, or the ID line. You will notice that we have some exposed rails, a ground rail at the bottom and a power rail at the top. And I've just been tying things to it as need be, moving them between. Now to feel ashamed of my bad soldering work. Okay. So yeah, I got both of my analog lines in some tasty yellow. And then I've got an exposed and an unexposed up here. And some solder lines, you know. Solder is a good conductor in it. But it's proto board. This is just this is before we have them printed out and shipped here. So, yeah. Just tying some lines together. Real basic stuff. Real bad, shoddy solder work. I'm gonna need to get a little bit higher quality solder for the kind of stuff I'm doing. Look at these bad joints, man. Makes me sad. Especially this one up here. Or this one down here too. Let's see. Look at that hole. I don't like it. And then up here is another one. Really don't like those holes. But, oh well. For the time being, it's good enough. So we'll just plug it back in. So what we got going on here is a SparkFun ATtiny programmer. I did a video on it a long time ago when I thought I could be a electronics YouTuber or something. Anyways, so now we're using it. I don't know why I taped this up, probably to make it easier to grip and stuff. But I'm just using some jumpers to jump it into this socket. For simplicity's sake, I don't want to have to be taking my ATtiny in and out of both of these sockets every time I want to test it, so that was the solution I came up with. So let's see if I can rebuild this. I'm just going to take all of those out and do them one at a time. Well, actually, we'll secure the boards before we try to put any wires in. Just, twist ties. It's better than most of my engineering solutions. Most of the time I just use hot glue. They ought to tell me that hot glue is not a building material, but guys, you really don't want to see my monitor mounting solution. That's fine. It's not fine. I hate it. There. It's better. There's no rhyme or reason to how we're plugging these in or what colors correspond to what. in case you were wondering. I need a little bit more light. Uno momento, por favor. Much better. Okay, last one. All right, let's plug our peripheral back in. Good enough for me. Let's get our serial monitor plugged back in. BRB. All right, so let's put our serial monitor back in place. We're using one of those little USB TTL converter cables. Nifty device, I like it. I like it a lot. So let's open up Putty again. No, Putty's already open. So Putty should be showing some numbers, that's good. And then we will add a window capture. Call it serial monitor. Ooh, I have an idea. Cool. Alright, so we got our serial monitor up. Now we can see that. That's very cool. Let's make that way big. Hella big, man! So we'll see what it looks like if I turn the peripheral off by flicking the switch. Now it's important I see what that looks like in code. So the thing still appears to be fairly wet, which is good. A little part of me wants to stick like something hot in this dirt and boil it off, but I think that'd be a really bad idea. What do you think? Alright, now as for the middle monitor, let's put a serial monitor here too. Ballin'. Okay, so now let's start doing some programming work on it, shall we? So, first thing to note, if we try to upload, we do in fact get an error. Yikes, invalid device signature. And we fix that error. Yep, looks good. Alright, so we're somewhere in the loop. Let's see what we get. So we got some stuff to make it go to sleep, put it to bed. We got some values. I'm gonna want to set a certain amount of cycles that it waters for. You guys don't mind if this is squashed, do you? No, you don't. Okay. So, let's see. People probably don't like if I'm using defines, but that's fine. We'll do another one anyways. Now I think these will be a bite or something. Let's do bite. Maybe it's volatile. What is this? Cycles to water? This is going to be in increments of 8 seconds, so 8, 16, 24, 48. Let's get the old calculatory device out. Oh yeah, we'll go 64. 8 cycles. Volatile? Nice. Yeah, so basically, this thing's going to stay asleep for 30 cycles, and each cycle is approximately 8 seconds, so about 4 minutes, and then it'll wake up, and if it's watering, it's going to water for 8 cycles, which is a minute. I'm gonna dial that down to 6? No, I'll dial that down to 5. 40 seconds. 40 seconds, 4 minutes. Cool. That's the theory, at least. That I want to allow time for the water to actually soak into the soil. So this thing might be activating in the morning and watering up until the afternoon. I have no clue yet. So we got that. Let's do in the main loop. And there's a boolean we're going to want to set, I think. Well, let's make our Boolean first. My brain just overloaded. I'm so sorry. A million methods I'm thinking. Let's see. What am I doing? Alright. So, if our Boolean is true, we're going to toggle the relay on. Otherwise, if our Boolean is false, we're gonna untoggle the Boolean. And then if the current cycle equals the cycle to water maximum of like 40 seconds, then we toggle that off. Continue sleeping until cycles to sleep. Now let's go ahead and hook up our relay peripheral. I would like to be able to see if this works. We're probably also going to have to set some test codes so that the sensor, when turned off, the sensor gives us a low value. There we go. It's probably not going to do anything yet. We don't have any code in here to toggle relay on, so let's see. Test sensors. Anyways, this sensor gives us a value between like 600 to 300, with 600 being the completely dry and 300 being the completely wet. So anything above that, and I know that I have disconnected the line, but we're going to use that for debugging purposes. So now this should give us nothing on the serial monitor for now. Uh-oh. Did you hear it? Uh-oh. Uh-oh. Oh no. We've made a blinky ass light. That would explain things. Let's put a little bit more moisture in there, huh? All right. Value looks like it's going down. So the soil is getting moister. I think that's about as stable as it's gonna get. Yep, there we go. I might just augment that so it's 335 as a value of 10. Cool. Okay. Uh-oh. It's still doing the thing. It is no longer doing the thing. Okay. Cool. So it's only actually toggling the relay on now if it detects low moisture, and we see it click on and off because up here I have the watchdog mode set to 2. If we want to put it to actual 8 seconds, then we set it to mode 9. So now we just have to figure out at what value we want this thing to start watering. And that might take some outside testing. And honestly, I think this is it. We show that when the soil is moist, the relay no longer toggles on. Oh, I suppose I ought to show you guys the battery for the project and the pump. We're going to use a double diaphragm pump, 5 volt to 12 volt, some good quality Chinesium here. A lot of our stuff's Chinesium. And then for our battery, we just pilfered one of these bad boys. You know, your run-of-the-mill pocket battery from Walmart. We just pilfered the battery and the charge circuit. We rubbed the charge circuit down with some waterproofing materials, and we tied an output here. So the charge circuit, the flow for this is going to be solar powered. The flow for this is going to be power comes in here, outputs to the charge circuit for the battery. So the battery is not going to run the AT Tiny. The battery is going to then the battery will then output to the relay, and the relay is controlled by the circuitry here. So the next step is to go see if the sun provides us with enough juice, or if we need to maybe consider putting a super cap into the mix. I'm hoping the sun provides us with enough juice. Oh, and just to be a dick, I used my hot glue to close off the USB because we're only using this thing to charge the battery. That's all we need is a 5 volt output to the pump. Pump moves water. Circuit reads measurement. Water is moist. And we're golden. So that's it for now, really. I could add some more serial debugging stuff, but meh, we'll see. Let's just go ahead and do that. Make my life a little easier. I don't like any of this. Yep, I'm cool with it. So, in actual application, I'll have to look at it and see if it just obsessively overwaters, and in the future I'm thinking if I want the soil to go dry for a little bit, I could have it water until the moisture hits level 10, and then at that point it flips a flag, and then it lets it sit until the moisture drops down to like level 8 or something. As of right now, we just have it watering anytime it's lower than 8. But yeah, we'll have to do practical applications and test it outside now. Now I've got to build something. Ugh, this is the part where having a 3D printer would be baller as fuck. So if anybody's out there wants to help me obtain a 3D printer, your monetary contributions would be much welcomed. Thanks for tuning in. We are done for today.